Welcome to lessons 2 and 3, our learning targets for today. I can define the word bisect, perpendicular bisector, and equilateral triangle. Our second learning target, I can make formal geometric constructions using a compass and a straight edge. Again, this is your ruler. The constructions we're going to complete today, we're going to bisect a segment, also known as a line segment. We're going to bisect an angle, and we're going to construct an equilateral triangle. Don't forget to refer back to your vocabulary packet from Friday, September 11th. It looks like this. Keep that handy and use that as we go through our constructions today. Moving on to construction 3, we're going to bisect a given line segment or segment, also known as constructing the perpendicular bisector of a segment. So we're given segment AB. We're going to construct the bisector of segment AB. Here are the definitions you need to know. They're listed here. They're also listed in your vocabulary packet from Friday, September 11th. We're going to follow these steps. First step, open your compass so the distance between the point and the pencil point is more than half the length of segment AB. So your point's on A, you want to stretch it so your compass length, your radius length, is more than half the length of segment AB. Step 2, using point A as a center, draw one arc above segment AB and one arc below segment AB. So you can do this all in one step. Stand it up. You now have an arc above and below segment AB. Step 3, using the same radius and same setting that we just used in step 2, but now point B is our center. So flip your compass point on B. We're going to draw another pair of arcs, again, above and below segment AB. And this arc is going to intersect the arc that we just drew. So if you notice, we have two intersection points. We have one above the segment, one below the segment. And the directions say to label the points of intersection C and D. Final step, use a straight edge to draw line CD intersecting segment AB at E. So we're going to draw a straight line connecting C and D. It's going to cut through segment AB. Where your perpendicular bisector hits your line, we're going to call that point E. Now, in fact, this is a perpendicular bisector to segment AB because if you notice, right angles are formed at point E. So if you want, you can put your right angles in. Remember that little box represents a 90-degree angle. Bisect means to cut in half. So here's your perpendicular bisector. It intersects your segment at E, which means E will be the midpoint of segment AB. Therefore, the length from A to E is congruent to the length from E to B. Now, to mark off congruent on a segment, you want to use a hash mark. AE is congruent to EB. You're going to complete the questions underneath the construction on your own, and we're moving on to construction 4. We're going to bisect an angle, also known as constructing the bisector of a given angle. So we're given an angle ABC. We're going to construct the bisector of ABC. Now remember what bisect means to do, to cut into two equal parts. So we're going to split this angle into two equal parts. Let's follow the steps. With B as our center and any convenient radius of your compass is just the distance between the point of the compass and the pencil point. So we're going to put the compass point on B. We're going to make an arc that intersects both sides of our angle. So it doesn't matter what your compass setting is, as long as when you construct your arc, it cuts through both sides of your angle. Now, we said that the arc intersects ray BA at D, so we'll put a D here, and ray BC at E. We're done with step 1. Step 2, with D and E as your center, and with equal radii of sufficient length, draw arcs that intersect at F. For this step, step 2, you are allowed to use the same compass setting you used for step 1. So you can hold that compass setting, put your compass point on point D, that point of intersection, create another arc, do the same thing from the other intersection point at E, create another arc. Those two arcs should intersect, and we said call the intersection point F. Final step, we're going to draw a ray from B through F. The conclusion. Angle ABF, which is the top angle, I'm going to put an arc here to show you. I'll use 2 arcs to denote the angle. Angle ABF is congruent to angle CBF, the bottom portion of that original angle. And again, BF is the angle bisector of angle ABC. Construction 5. Hold on 1 second. I have to grab construction 5 from the other packet. We're going to construct an equilateral triangle. Given segment AB, we're going to construct an equilateral triangle using side or segment AB as the side of the triangle. Remember what an equilateral triangle is from our definition packet. It's a triangle with 3 equal sides and 3 equal angles. So we're going to follow the steps. Step 1, put the compass point on A, pencil point on B. So we're measuring the length of this side from A to B. Step 2, holding that setting, keep the compass point on A and construct an arc above A or above segment AB. There's our first arc. Using the same setting, put the point of the compass at B. So all I'm going to do is flip it over, compass point on B, construct an arc above B. When you construct this second arc, it should intersect with your first arc. We're going to label the point of intersection C. Final step, we're going to draw a segment from A to C and from B to C. So using your straight edge, from A to C and from B to C. And what we know about this triangle, since it's equilateral, all 3 sides are equal. Remember, we use hash marks to denote equal sides, and all 3 angles are equal. We use arc marks to denote equal angles. And I want you to think about these 2 on your own. How would you construct a 60-degree angle, and how would you construct a 30-degree angle? Now remember, there's 180 degrees in every triangle. So that means if you divide 180 by 3, you're going to get 60, which means each of these angles at A, B, and C are 60.